What's up, guys? Welcome back to the channel. Today our problem is called unique path. It's a problem being asked by companies like Google, Facebook and Amazon, so let's look into it. Let's look at the problem description. It says that a robot is located at the top left corner of an M cross N grid. The robot can only move either down or right at any point in time. The robot is trying to reach the bottom right corner of the grid that is marked as finish. How many possible unique paths are there? So we have this grid, M cross N grid, and the robot is at 0, 0. It wants to reach the finish point, that is the bottom right corner, or we can say M minus 1, N minus 1 point in this grid. And we need to find out how many possible unique paths are there by which it can do that. The condition is that this robot can either move in the right direction or downwards, so it cannot move left or it cannot take a step above itself. So there are only two possible direction in which it can move. And let's simplify this problem and let's try to find out how many ways are there by which this robot can reach a position just immediate to its right. So there is only one way, right? It can take a step to the right and reach that position. Now let's think how many ways are there by which this robot can reach a position 3 cells to the right. Then also there is only one way, because it can keep moving on to its right and reach that position. We need to note that we are trying to find possible unique paths. We are not counting the number of steps. So to reach a cell 3 point away from it, it needs to take 3 steps, but there is only one way to do that is just keep moving to the right. In the same way, to reach a cell that is immediately below it, or anywhere in the same in the same column, then there is only one way to reach that positions. The robot needs to keep moving downwards to reach that position. So this is our first point. To move in the same row or to move in the same column, there is only one way to do that. Coming to the second point, we need to find out how can this robot move diagonally. This robot can move diagonally in two ways. Either it can move right and then down to reach the immediate diagonal, or it can move down and then right to reach the immediate diagonal. So these are the two concepts that we are going to use to solve this problem. Now let's think about, we need to reach the finished position. If we know how many ways are there to reach a cell just above it, then we know we can reach finish by taking a step down, right? And also if we know how many ways are there to reach a cell just to its left, then we know we can take a step to the right and reach that position. So if we add these two possibilities, so basically the number of unique paths by which we can reach a cell just above finish, plus the number of unique path by which we can reach a cell just to the left of finish. If we add these two, we'll get the number of ways to reach finish, right? So this is a typical dynamic programming problem. Again, it's just reframed in a new way, where we'll keep on storing the number of unique paths that are there to reach any position, let's say I comma j in this grid, and whenever in future we need that, we can reuse that. So let's start coding it. By the way, if you need to know the basics of dynamic programming or know how to use it and when to use it, then there is a video that I have done. You can find the link somewhere here or maybe in the problem description, in the video description. So let's start coding it. We need a 2D array that will store the number of unique paths. Let's call it dp, and this will be of size m comma n, which will store the number of unique paths at any position in this grid. Let's iterate through this grid and we'll try to populate the number of unique paths for each of the position, and in the end, when we are finished with this loop, we'll have the number of ways to reach the bottom right corner. So we will need two loops to do that, two recursive loops. Not Yep. So let's initialize our jth pointer, one for the row, another for the column. This is basically how you traverse grid. Now we need to write a first condition where if I double equals to 0 or j double equals to 0, then what will you do? So what do we mean by I double equals to 0 or j double equals to 0? We mean that we are talking about the topmost row or the leftmost corner. And as I mentioned earlier, there is only one way to move in a row or in a column. So we can mark this position as like the number of ways to reach any cell in the topmost row or the leftmost column as 1, because there is only one way to do that. We can keep on moving to the right, or we can keep on moving to below us. So let's yep, so that is the logic behind it. So let's mark these positions as 1, because there is only one way to do that. So let me set dp of I equals dp of I comma j as 1 in this case. Else we can we know there are only two ways by which we can reach any cell. Either we came from above or from the left. So we can add those two values and get dp of ij. So we can say dp of ij equals to dp of I minus 1 comma j, or we can say we came from above us, so we can say dp of I comma j minus 1. So there are only two ways, right? I think this should be good enough. In the end, we can just return dp of m minus 1 comma n minus 1. That is the bottom right corner, and that is the finish. I think I missed yep, I missed this bracket. Yeah, so let's return dp of m minus 1 comma n minus 1. That will contain our number of unique paths by which we can reach the finish position. And I think that should work. Let's submit it. Oh, we have one error. What is wrong? This should be equals to, not double equals to. Let's run it again. Oh, so we missed a semicolon here. Let's now it should be fine. Let's run it. Yep, it works. Awesome. Let's submit it. So the runtime is 0 ms. It is faster than 100% of Java Online Submission because we use dynamic programming. So if you liked my solution and if you want to see more such videos, then you can like this video and subscribe to my YouTube channel. And if you have any doubt in this problem, or if you want me to solve any other coding problem, you can comment that below and I can take a look. And I think that's all from my side.